Students, the next topic is Hdfs Architecture. This architecture plays a major role in storing the large amounts of data into Hadoop cluster. This architecture is used to store large amounts of data, that is big data, into Hadoop cluster. To store big data into Hadoop cluster, the prerequisites are: we need to form a cluster first, cluster of n number of machines. N can be anything, depends on your requirement, like 10, 20, 30, 100, 200, 300, it depends on the data which you are going to store. And after setting up the cluster, you need to install the Hadoop software on top of the cluster. Meaning we will be installing the Hadoop software in the client machine. Students, this cluster contains slave nodes, master node and client machine. These three will be having slave nodes, master node and client machine. After setting up the cluster and installing the Hadoop, after successful installation of Hadoop, now we can store the large amounts of data into the cluster. To store that large amounts of data into cluster, I need to start the Hadoop first. I need to run the Hadoop environment first. To run the Hadoop environment, we are having few commands. Those commands I will be discussing in my next lecture. For time being, we just follow the session. Once the Hadoop environment is up, there will be 3 services running in the cluster. There will be 3 services running in the cluster. What are those 3 services, students? The 3 services are name node, data node, secondary name node. The first service is or daemon is name node. The second service is data node. The third service is secondary name node. The name node and data node plays a major role here to store the large amounts of data. These I am calling it as daemons. Daemons means the program which is in execution is known as process, isn't it? Similarly, the process which runs in the background is known as a daemon or a service. These are all the programs. Name node is a program, data node is a program, secondary name node is also a program. These programs will run in the background. Okay, so we are calling it as a daemons. Now, this data node will be running in the slave machines. The data node program will be running in all the slave nodes. Similarly, the name node will be running in the master machine only. The Hadoop architecture, the Hadoop follows the master-slave fashion. There will be a one master and many slaves. Master should be only one and slaves can be n number of, depends on our requirement. Okay, students? Fine. The data nodes will be running in the slave machines and the name node program will be running in the master machine. Okay, fine. Now, once these services are running, now the user can submit his request to the client machine. The user can submit the request. What is the request here, students? Storing whatever the file he needs to store it into the Hadoop cluster, that file he needs to submit it to the Hadoop client machine. Here in the entire cluster we'll be having client machine, we'll be having master and we'll be having slaves also. These three will be having client machine, master machine and n number of slaves. The user will submit the request to the client machine, Hadoop client machine. Once how he will submit the request to the client machine? For that also we are having few commands. As I said earlier, we will be discussing these commands in the next lecture. Once the user submits the request to the client machine, which request he has submitted? The user wants to store 100 terabytes of data. If you see the architecture, the user is going to submit 100 terabytes of data into the cluster. The user wants to store 100 terabytes of data into Hadoop cluster. 100 terabytes of data into Hadoop cluster. Terabytes usually we'll call it as a big data only. So this architecture is suitable to store big data only but not small amounts of data. Fine. Now once the user submits the request to the Hadoop client machine, now the client machine will take that request, will take that file, that 100 terabytes of data, and it will first divide those into number of blocks. That 100 terabytes of data will be divided into n number of blocks, and each block size is 128 MB. Each block size is 128 MB. Students, again, I have to specify one thing here. The block size which I told is 128. The block size of Hadoop Hdfs architecture is, the block size of Hdfs architecture is 128 MB. It again depends on the version of the Hadoop. If we are using Hadoop 1.x version, the block size is 64 MB. If we are using 2.x versions and above versions, the block size will be 128 MB. It depends on the versions we are using. As I assumed that we are using Hadoop 2.x versions, the latest versions, the block size is 128 MB. So now the Hadoop client machine will divide this file into n number of blocks. Each block size is 128 MB. I have given the mathematical calculation over here. Students, if you observe here, 100 terabytes, I need to divide it into megabytes first, and I have to divide it with 128. Then I will get number of blocks. Here I have taken 1 TB is equals to 1024 gigabytes. 1 TB is equals to 1024 gigabytes. Similarly, 1 gigabyte is equals to 1024 megabytes. I have used these measures to calculate the number of blocks. If you see here, 1 terabyte is equals to 1024 gigabytes, and 1 gigabyte is equals to 1024 megabytes. I got this many number of, I got this data, this MB of data. I have divided it with 128. Finally, I got 8,19,200 blocks. If I divide 100 terabytes of data, how many blocks I am going to get? If each block size is 128, 8,19,200 blocks I am going to get, students. Okay, these many number of blocks I need to store it in the Hadoop cluster. Okay, fine. Students, storing 8 lakhs of blocks into the cluster is a really tedious task to explain actually. So what I am going to do is, in this session, I am going to take a small amounts of data, that is 500 MB of data. Usually students, once again I am repeating, 500 MB of data is very less amount of data. We won't use Hadoop to store these megabytes of data. Remember, for simplicity, to make my session simple and to make you to understand this concept, I have taken 500 MB of data. Okay, but 500 MB of data, to store 500 MB of data, no need of going for Hadoop. The normal SQL databases are enough to store it and to process it. Okay, for simplicity purpose only I have taken this. So this 500 MB of data, the user wants to store it into the Hadoop cluster. So what the Hadoop client machine will do first? It will divide that data into blocks. The client machine will divide this 500 MB of data into number of blocks. Each block size is again 128 MB. If you see the calculation, the number of blocks we got is 4 blocks. 500 MB will be divided into 4 blocks if each block size is 128 MB. Okay, students, fine. So the Hadoop client machine divided this 500 MB of data into 4 blocks. Each block size is 128 MB. Again, the fourth block, block 1 will be 128 MB, block 2 will be 128, block 3 will be 128, block 4 won't be 128. Okay, that will be little lesser. We need to see that calculation. Okay. So once the Hadoop client machine divides this into blocks, now we need to store these blocks into Hadoop cluster. So where to store? Students, the data the blocks always get stored in the slave machines only, in the data nodes only. Where will the data nodes running? In the slave machines. So the original data, here the original data meaning the file data, the 500 MB of data. This data will be storing inside the cluster only, meaning inside the cluster in the sense not in the master machine, but in the slave machines only, but not in the master machine. So the Hadoop client machine does not know where to store, I mean in which slave nodes these 4 blocks needs to store. That information the Hadoop client does not have. So what the Hadoop client machine will do is, it will send a request to the master node, that is name node. The client machine will send the request to the master machine asking like, hey name node. It will ask the master machine. Who will be running in the master machine? The name node will be running in the master machine. The name node will receive that request. What is the request? The client machine will be asking something like this to the name node. Hey name node, I am having 4 blocks with me. I need to store these 4 blocks in the data nodes. Could you send me the details? Where can I store these 4 blocks? In such a way, the request will be sent to the name node in the master machine. The name node receives the request. As soon as it receives the request, students, the name node will be maintaining a file called metadata. Listen carefully, this is very important one. The name node will be maintaining a file called metadata. In the topic Hdfs daemons, I have discussed this. Name node will contain metadata. Data nodes contains the original data. The name node will be storing a file, which is a very important file called metadata. Metadata means the data about the data. The data which represents something about another data is known as metadata. The data which represents about the another data is known as metadata. Here, this metadata represents about the original data. What is original data? 500 MB of data. The details of this metadata is about that data only. It opens the metadata and it scans that metadata file. What will be written in the metadata? The metadata contains everything about the file which is already stored in the Hadoop cluster. Listen carefully. The metadata file contains the file information, the large file which we already stored. Assume that we already stored something in the Hadoop cluster. That file information will be stored in the metadata. Which file? What is the name of the file? Who has the permissions to access that file? That file blocks are stored in the blocks of the files are stored in which slave nodes? What is the IP address of those slave nodes and all? What are the replications of that? Where the replications are stored? All these information will be dumped into the metadata file. Okay. So initially I'll be discussing 3 cases here, students. The case 1 is, assume this is the first file I am going to store in the Hadoop cluster. This is the first file, 500 MB of data. This is the first file I am going to store into the Hadoop cluster. Previously, the Hadoop cluster does not contain any information. Empty. The cluster is empty. This is a case 1. In case 1, the metadata file does not contain anything. The metadata file is empty, does not contain anything because there is nothing in the cluster. There is no data in the cluster. So, there will be no information in the metadata also. So, the metadata is empty. Now, in this case, I want to store these 4 blocks into Hadoop cluster, isn't it? For that sake, the client machine has sent the request asking like, where can I store these 4 blocks? In which slave nodes? If you see the architecture, we are having 9 slave nodes here. Okay. Among these 9 slave nodes, in which slave nodes these 4 blocks will go and sit? That information should be passed by the master node, that is from the name node. For that only the client machine has sent the request. Okay, fine. Now the name node, what it does, it opens the metadata file, but there is nothing in the metadata file, empty. So what it thinks like, okay, fine, the cluster is empty, there is nothing in the cluster. So the name node will take a decision like, it will randomly pick 4 slave nodes among the 9 machines and passes the IP address of those slave machines to the client. Students, once again I am repeating, the name node picks randomly 4 data nodes. Why 4 data nodes? Because I need to store 4 blocks, no? To store 4 blocks will be stored in different nodes. No 2 blocks will be stored in the same machines. Listen carefully. No 2 blocks will be stored in the same slave machines. The 4 different blocks needs to store in 4 different slave nodes only. For that purpose, the name node will randomly pick 4 slave nodes and sends the IP address of those slave nodes to the client machine. Understand, students? Now, the client received the IP address information. The client is the responsible person to write these blocks into the Hadoop cluster. Understand? Once again I am repeating. Once the client receives the IP addresses of the slave nodes, now the client machine will write the blocks into the Hadoop cluster. It will distribute the blocks into the cluster. This word is very important, students. Distributes. We are not going to store it in a centralized one. We are going to distribute among the cluster. Okay, so it distributes these 4 blocks into 4 different slave nodes. Who is going to write the data? Is it master or client machine? Client machine. Be careful, everyone will get confused here. Everyone will say that master will write the data into the slave nodes. No, master won't write the data into the slave nodes. It is the client machine who is going to write the data into the slave machines. These blocks will be written into the slave machines by the Hadoop client machine only, but not by the master machine. The master machine acts as an interface between the user and the slave nodes. That's all. Okay, students, now where does the data stored? In the slave nodes. In the slave nodes. Slave nodes contain which services? Data node services. Once the client machine sends the data to the slave nodes, there in the slave nodes there will be a data node service running. That data node receives that block. The data node receives that block and writes that data into the corresponding hard disk. Okay. The client machine will send the data to the slave machines. Inside the slave machines, the data node is running. The data node will take that data and it will write it into the hard disk. Machines will be having hard disk. So in the hard disk only we are going to store the data. Okay, it will write it into the hard disk. So here B1, B2, B3, B4. B1 is stored in data node 1. B2 is stored in 3. B3 is stored in 4th data node. And B4 is stored in 7th data node. Okay, fine. So now the blocks are stored in the cluster. Block B1 is stored here, B2, B3 and B4. B4 blocks are stored in the slave nodes, that is in the data nodes. So students, are we done with the storage part? I've stored the data? No. Over? No, we just done with the 20% of the architecture. We need to discuss 80% of the architecture still. So, ma'am, what is there to discuss? We have started the Hadoop. The user has submitted the file. That file has divided into blocks. Those blocks are successfully stored in the Hadoop cluster. Now I'm having the data. No. Still, what is there to discuss? Isn't it? You've successfully stored the data. So what is there to discuss yet? It's there. Students, look at this architecture. Would you find any limitations or drawbacks or flaws in this architecture? Think once. I will give a couple of seconds for you. By looking at this architecture, after storing the data, do we find any problems? Any drawbacks here? Think. There is a flaw in this architecture. There is a limitation in this architecture. What is that limitation? Students, we have stored the blocks, no? B1, B2, B3, B4. The blocks which I stored in the cluster, the blocks where I stored, in the cluster. Cluster is made up of commodity machines. Cluster is made up of commodity machines, but not high-end machines. Commodity machines means very economically affordable machines as well as low performance machines. There is a chance of failure of these machines. Students, if you take our systems, systems which we are using currently in our homes, in our organizations, 365 into 24/7, they won't work. Sometimes they may crash, they may fail. At that time, whatever the data we are having residing in our systems, we may lose. Isn't it? If the system gets crashed, we may lose. What if the blocks which I stored, this is a cluster which is made up of such machines only, commodity machines. These are not high-end machines. There is a chance of failure of these machines also at times. What if the blocks which I stored in the cluster, those machines got failure? For suppose like B2 or B4, B2 or B3. The slave nodes wherein we stored the B2, B3 or B2, B4 got failed, I lose the data. Isn't it? The part of the data I'm going to lose. Students think it in otherwise. For example, I'm storing some sensitive data into the cluster. For example, let's take some SBI high authority person came to me and asking to develop some application in Hadoop, and he has given me some file, some data to store it into the Hadoop. I have taken those and I have stored in the Hadoop cluster. And on one day, the Hadoop cluster, some of the machines in the Hadoop cluster, some of the slave nodes in the Hadoop cluster got failed or got crashed. Then there is a chance of losing the data. I may lose the data, isn't it? I will lose the data. For example, if I store these 4 blocks, among these 4 blocks, if I lose 2 blocks, gone. I was gone. I will be behind the bars only. Those people will take me and put it in the behind the bars only. Isn't it? Those are sensitive data. Customers' data is sensitive data. I cannot easily lose that data like that. So what is the problem here, students? What if the data nodes get failed? What if the data nodes get failed? Is there a chance of failure or not? Yes, because these are the slave machines which are made up of commodity, which are commodity machines, very low performance machines. Then you may get it out, ma'am, if it is a low performance machines, then why we are going to use those machines? Can't we go for little high performance machines? Yes, the question is valid one. But think it once, if I am going to form a cluster of some 10,000 nodes, I have to buy 10,000 high-end machines. I cannot afford that much amounts of money, that much amount. Okay, I can afford to 1 or 2 high-end machines, but not 10,000, 20,000 servers. For that sake, I'm using the commodity machines. If I use the commodity machines, there is a chance of failure of those machines. If those machines got failed, what will happen? I will lose the data. I will lose the data. Losing the data is the biggest drawback, biggest disadvantage. No, I should not lose the data. So the problem with this architecture is, what if the data node gets failed? For suppose B2, B4 got failed, I will lose the data. So at that time, students, when the people, Dow Cutting and Mike Caffarella, started designing this architecture, they have found this flaw, they have found this problem, and they have come up with a solution. The solution is simple. Take the backup. Take the backup. Duplicate the data. How many times should I duplicate the data? 3 times you need to duplicate the data. The replication factor is 3. Students, listen carefully. This is a very important interview question. What if the data nodes get failed? We will take the backup. How many backups we are going to take? 3 backups we are going to take. That I am calling it as a replication factor. What is the replication factor of Hadoop? The replication factor of Hadoop is 3. 3 times. Each block is stored thrice in the Hadoop cluster. If one data node gets failed, fine, I'm having 2 other. From those 2 other, I can form the 3rd one again. Isn't it? So at all the time, there will be 3 replicas of each block. There will be 3 replicas of each block. It is mandatory. Take it as granted. In Hadoop, each block should be replicated thrice. If you take B1, needs to replicate twice. If you see this, see, I have replicated the data. If you take B1, B1 is stored in data node 1, data node 6 and data node 7. Similarly, B2 also. B2 is stored in data node 2, data node 4 and data node 9. Likewise, each block is replicated thrice. For what we are going for replication, students? In order to not lose the data. As we are using the commodity machines in our cluster, there is a chance of failure of those machines. So in order to overcome that problem, we are going to back up the data. We are going to replicate the data. How many times we are going to replicate the data? 3 times. Again, student, this replication factor can be reconfigured, can be editable. You can change this replication factor. You can go for 2, you can go for 4, you can go for 5. It depends on your requirement, and again depends on the sensitivity of the data also. If the data is so sensitive, go for 4 or 5 replication also. That's okay. Okay, and this can be reconfigured in the file called Hdfs-site.xml. As there are few XML files which I will be covering in some later classes. We need to discuss those XML files. What are all we can configure in the XML files? We will be discussing. This is one of the XML file, Hdfs-site.xml file. In that file, we can reconfigure the replication factor. Okay, students. So, what is the problem in this architecture? What if the data nodes get failed? What is the solution they have given at the time? Take the replication. Take the backup. How many backups they are taking for each block? 3 replications. Done? Okay, fine. Still, are there any flaws or limitations in this architecture? Think. Before that, students, I need to tell one more thing here. Once the data is stored, we have discussed till now, right? The user will be submitting the request to the client. The client will be requesting for the master where to store the blocks, and the master will be responding with the IP addresses and all. The client machine will write the data into the slave nodes. Here, when the client machine sends a request to the master machine, the master will send the, as I said in a couple of minutes back, the master sends the 4 IP addresses. I said that the master will send 4 IP addresses because we are having 4 blocks here. But students, as I have specified the replication here, the replication where I should take put the backup of these blocks, those IP addresses also will be sent by the master to the client. So total here in this case, in this architecture, which I have showing for you, in this architecture, the 9 slave nodes IP addresses will be passed to the client machine because the blocks and its replications both needs to be stored, right? For that purpose, this information is sent to the client machine. The client, he won't send those many number of replicas to the slave nodes. He will just only one copy. B1 one copy, B2 one copy, B3 one copy, B4 one copy. Only 4 blocks will be sent from the client machine to the data nodes, different data nodes. Now, for example, B1 is stored in which data node? Initially, whatever the 3 replicas I am speaking, those 3 replicas, the first replica I am calling it as primary data. The second one is secondary replica A, secondary replica B. Three backups I am going to take. No, the first one I am calling it as primary data. The second replica I am calling it as secondary replica A. The third replica I am calling it as secondary replica B. Okay, so the client machine will send the primary data. Only one block it will send. Block 1, block 2, block 3, block 4. Once the data node stores that blocks into their machines, for example, let's take B1 for simplicity. The B1 block will be sent by the client machine to the data node 1. Okay, data node 1. The data node 1 will store block 1 into its hard disk. After storing, the client machine will send the IP addresses of the other slave machines where the secondary replica A, secondary replica B needs to be stored. Understand? I'll repeat once again. I'm taking one block. There are 4 blocks, but with one block I'll be explaining this concept. For example, block 1. I need to store block 1 in the slave machines. Block 1 will be stored how many times, students? 3 times we need to store because the replication factor is 3 here. Isn't it? Fine. Now the client machine will send only one block, one copy of block 1 to whom? Assume to slave node 1. Okay. So B1 is stored in slave node 1 here. And also the Hadoop client machine will send the 2 IP addresses information to the slave node 1. The 2 IP addresses are for what? For replication of secondary A, secondary B. Where are the B replicas? Other two replicas are stored here in this architecture. One is in 6th data node, another one is in 7th data node. So those IP addresses also sent by the client machine to the B1 block slave node. Initially B1 is stored in data node 1. After storing, it also gets the information like you need to store the replica of the same B1 in other 2 machines also. Now the data node, this data node, B1 data node, this data node 1 will send the copy of that block to those 2 slave nodes. That is 6th slave node and 7th slave node. Now the slave nodes will receive those 2 blocks, each block and stores in their hard disk. After successful storing, the 6th data node and 7th data node, B1 is stored here. These 2 slave nodes are, these 2 data nodes, the data node will be running in the machine, right? These 2 data nodes will send an acknowledgement to the primary replica. These 2 data nodes will send an acknowledgement to the primary replica saying that, hey, primary data, I have stored the data which you have sent to me in my hard disk successfully. Once the primary replica receives that acknowledgement, then the primary replica will send the block report to the master. Understand? Should I repeat once again, students? Once the client machine will send the block, along with the block, it will also send one more information. What is that information, students? The IP addresses of the second replica A, second replica B. That information will also send to the corresponding primary replicas. Let us take block B1. Block B1 is initially primary replica, primary data is stored in data node 1. Okay. After successful storing of that block into that node, what does the data node will do means, it will take that copy, B1 copy, and it will send to the IP addresses of 6th data node as well as 7th data node. And those 6th data node and 7th data node receives those blocks B1 and stores it itself. After successful storing of those blocks, it will send the acknowledgement to the primary replica. Once the primary replica receives the acknowledgement, it will send a block report to the master saying that what does that block report represent? It says that, hey master, whatever the data I need to store in myself, I have stored successfully. You update your metadata. You update your metadata. In such a way, the acknowledgement will be sent as a block report to the master. Similarly, the other blocks also, block 2, block 3, block 4 also sends the acknowledgement as a block report. What does the block report represent, students? The block report represents that the slave nodes, the data nodes have successfully stored the so-and-so blocks in themselves. That information will be carried to the master. Now the master will update the metadata. What metadata it will update? What blocks are stored? What blocks are stored? B1, B2, B3, B4. Of which file? Assume the file name is XYZ. XYZ file has 4 blocks. Those 4 blocks are stored in so-and-so IP addresses. Those file has permissions for so-and-so users. And the replicas of those blocks. What are those? The replicas of those blocks are stored in so-and-so IP addresses. All these I'm calling it as a metadata. Metadata means the data which describes about the another data. This data is describing about which data? The original data which is stored in the Hadoop slave machines, Hadoop cluster. Understand? Now the metadata file is empty or it has some data? It will have some data because I have stored the data. Once the data is successfully stored in the cluster slaves, the data nodes will send a block report to the name node saying that you whatever the data I need to store, I have stored in myself successfully. You update your metadata. The metadata will be updated in such a way that the file name, the file has so and so blocks. Each block is stored in which IP address, and the replicas of those blocks are stored in so and so IP addresses. This entire information will be dumped into the metadata file. This is a story behind storing the data into the Hadoop cluster. If you see the flow once again, the client will request the master for where to store the data. The client will be sending the IP addresses for primary replicas as well as secondary replicas, 2 secondary replicas. Once the client receives those information, the client will write the data into the primary blocks first. Once the data nodes writes the primary blocks in themselves, all the primary replicas will send the same copy to the secondary replica A, secondary replica B. Once the second replica A, second replica B has been stored the data successfully in themselves, those will send the acknowledgement back to the primary replica saying that I have stored the block successfully. Once the primary replica receives the acknowledgement from the secondary replicas, the primary replica data node will send an acknowledgement. We are calling that as a block report back to the master. Once the master gets the block report, it updates its metadata. Okay, fine. So this is the story. Students, think once again. Do you have any other problems, any other drawbacks, any other flaws in this architecture? First flaw we have identified and we have given the solution also of that. The second one is, what if master node gets failed? It is also a commodity machine, no? We identify that what if the data node gets failed? What if the name node gets failed? It is also a commodity machine. There is a chance of failure. So what, madam? Name node does not contain any data, no? Actual data is residing in the data nodes. Data nodes are fine. They took the replication. What if the name node fails? Nothing will happen, isn't it? Because we don't have any data in that. Whatever the data we need, that all are present in the Hadoop cluster safely, securely. If their name node fails, that's okay. Leave it. Is that so? No? Yes, no. It's the biggest failure actually than the data node failure. If name node fails, if master node fails, listen carefully. Master node, name node is a single point of failover. Single point of failover. Meaning, what does that mean? If name node got failed, everything is inaccessible in the cluster. Everything is inaccessible in the cluster. Meaning, though we are having the data, original data residing in the slave nodes, in the data nodes, but which block of which file is stored in which data node, that information is maintained by the name node. That information is maintained by the name node. What if the name node gets failed? Gone. How come I know which data is stored in which block? How can I retrieve that without that metadata file? If name node gets crashed, that metadata file is gone. No, we don't have that metadata file. Without that metadata file, how we are going to access that data? I don't know where which file of which block is stored in which slave node, which data node. Assume there are some thousands of slave nodes in the cluster. How come I know as a user which block of which file is stored in which data node? That information knows only by the master node, only by the name node. What if the name node gets crashed? That is a single point of failure. If name node gets crashed, everything is gone. Entire cluster is inaccessible. Though we are having the data residing safely in the cluster, but we don't know the information to retrieve the data. Isn't it? Yes. Students, for this I'll give an example. A normal day-to-day life example, so that you will come to know the significance of name node. Ashu, my HOD asked me one day, called me and asked me, Chandrakala, I'm giving some books to you. You just put these books in the storeroom. She asked in such a way. I collected those books. I went to the storeroom. I have placed in some racks. Those books are Arjun, some software engineering, Java, Hadoop, Python, Flat, CD, cloud computing, all those books. I have placed in some racks. What I did is, I have taken a piece of paper. I have just written in that piece of paper. SC book is stored in rack 1. Java book is stored in rack 3. Python book is stored in rack 5. CD book is stored in some rack 10. Likewise, I have written. The next day also, she called me and she gave me some more books. I collected it and again I have stored in the storeroom. And again I have updated this paper. Again, SC textbook, some rack. Java textbook, some rack. Flat textbook, some rack. Cloud computing textbook, some rack. Likewise, she used to call me daily and handing over few books and asking me to put it in the storeroom. Likewise, for 6 months she did. I am doing the same task. Keeping the books in the racks, updating my piece of paper. Like after 1 or 2 years, assume the storeroom is very big. I have placed some lags of textbooks in that. Okay. After 1 or 2 years, she again called me and asked me, Chandrakala, could you please get me SC textbook from the storeroom? So I said that, yes ma'am, I'll get it. And again, what I will do, at that time what I will do, I will open my piece of paper from the back, isn't it? Yes. I will see where that SC textbook is located, in which rack I have placed it. SC textbook at rack number 6. I'll go to the storeroom, pull out the textbook, hand it over to the HOD man. So easy, no? It's very easy. What if I didn't maintain this piece of paper? If she asks like, go and get some SC textbook in that big storeroom, where can I search? For what can I search there? It's a very horrible task for me, isn't it? This piece of paper helped me a lot. Now, this piece of paper, I am calling it as a metadata. This piece of paper is a metadata. Understood? Without this paper, is that possible for me to search 1 lakh textbooks in the storeroom? Highly impossible. It will take a lot of time for me to search for the data. The original data is textbooks. The textbooks are residing. But what if this paper I lost? Isn't it? If name node gets lost, what we are going to lose? Metadata. Isn't it? The same way, if I lose this paper, though I am having the textbooks placed in the storeroom, to access those textbooks, I may require 6 months, 1 year or so to search the books in that. The same concept applies here. If I lose the metadata, the data which describes about the original data, which is stored in the clusters, Hadoop clusters, slave machines. If I lose this metadata, gone. Entire cluster is inaccessible. I cannot access the cluster. I don't know which block of which file is stored in which data node. Where are the replications of those? Highly impossible. Very hectic task. If without the metadata to identify the file and to set the file. So only I am telling that name node is a single point of failover. If name node gets crashed, gone. Entire Hadoop cluster is inaccessible. Then what is the solution for this? Students, at that time, the people has identified this problem and they have come up with a solution. Here they have given 2 solutions. In Hadoop 1.x version, when they release Hadoop 1.x version, at that time, the solution for this is Hadoop 1.x version. The solution is run the name node in a high-end machine, in a server. I cannot afford n number of high-end machines, but I can afford for a single server, no? One single high-end machine. So I will buy only one single high-end machine. As master node is only one, I will buy one single machine and I will run the name node in that machine. Problem is solved. Usually the high-end machines won't get crashed. 99.99% the high-end machines will work until and unless some natural disasters happens. Those are high-end machines. Don't compare high-end machines with the competitive machines. Those two are two different opposite terms. Okay, very high performance machines. High-end machines means very high performance machines. Okay, run the name node in the high-end machines. This is solution given in 1.x version. In Hadoop 2.x version, they have come up with one more solution called standby name node. Take the backup of name node. Take the backup of name node. Whatever the backup we are speaking about, that will be stored in another machine. In that machine, one service will be running. That service I am calling it as standby name node. Backup of name node. Okay, students? We have identified two problems. What if data nodes get failed? If the data node, to overcome that problem, we have used the replication factor. What if the name node gets failed? If you are using Hadoop 1.x version, run the name node in high-end machine. If you are using 2.x version, by default, standby name node will be there. That will take the backup of the name node. So we have identified two problems and we have given the solutions for that. Okay, these two are the very important questions for the interview. This is important for exam point of view as well as most important for the interview. They will ask something like this. What is the replication factor of Hadoop? The replication factor of Hadoop is 3. What if data node gets failed? We are taking the replication. So there is no failure of data node. There will be a replication. No? So though the data node gets failed, yes, we do have the backup. What if the name node gets failed? In Hadoop 1.x version, we have to run the name node in high-end machine. In 2.x version, we are having a separate service called standby name node. That is a backup of name node. Who is a single point of failover in Hadoop architecture? Name node is a single point of failure. These three are the topmost interview questions which you can get in your interview. So, concentrate. Okay, students. What is metadata? This is also important. Metadata means the data which describes about the another data. Here in this case, the data which describes about the original data is known as metadata. Who maintains the metadata? Name node maintains the metadata. Who maintains the original data? Data nodes maintain the original data. Two services are most important here. One is name node, another one is data node. Name node maintains metadata. Data node maintains original data. Okay, students? What if name node fails? What if data node fails? What is the replication factor? Where can I change the replication factor? In Hdfs-site.xml file. Understand? So the students, we have discussed few issues and also corresponding solutions till now, like data node failure, name node failure, about the block report. The block reports will be sent by the primary replica of the blocks of slave nodes to the master. Once the block reports are received by the master will update the corresponding metadata file. Till now, from last 20, 30, 40 minutes onwards, we have discussed this concept. And we do have one more issue in this architecture, the final issue which we will be discussing now. And with this issue, we will be winding the architecture, Hdfs architecture. Okay, students? Fine. What is that issue? Students, we have seen that the data node failure, if the data node got failed, the solution for that we have seen is taking the replication, taking the backup of that data. Okay, fine. How come? Here in this case, we have one more issue. What is that issue? The issue is if the data node got failed, assume the data node got failed, will that information needs to be known to anyone in the cluster? Once again, I am repeating, students. if any data node got failure, yes, we have the solution for that. We have taken the replication, we have taken the backup, so the data won't get lost. But still, we have one more issue in this. That is, if any slave machine got crashed, got failed, then that particular machine, that particular information needs to be known to the master. Needs to be known to the master. For example, if let's take in our real life, whenever I or some other persons are off to the workplace, then we need to intimate to our boss, isn't it? That is a hierarchy we usually follow. In the same way, whenever a data node gets failed, that information needs to convey to the master. Whenever the slave node got failed, then that information needs to be known to the master. Who is the master here? Name node. Who is the slave node here? Data node. So whenever a data node gets crashed, the corresponding information needs to be shared to the master, that is name node. Why, for what kind of need we need to share that information to the master? One may get this doubt. We will look into that in the next 10 minutes, in the next 5 minutes. Students, so how come the master knows? Listen carefully. How come the master knows that the corresponding slave nodes are working? Whatever the slave nodes are present in the cluster, how come the master knows that every node in the cluster, every slave node in the cluster, every data node in the cluster is working fine? Is working fine. How come the master knows that information? For that, this architecture has given a solution saying like, from each slave node, listen carefully, from each slave node, the master receives the heartbeat signal. The master receives the heartbeat signal. This word is very important. From every slave node needs to send a heartbeat signal to the master. What does that heartbeat signal represent? It represents that that particular data node is alive. Every data node has to send a heartbeat signal to the master saying that that signal represents that that particular data node is alive. Just like a human being, how come we say that I am alive? We are alive through our heartbeat, isn't it? In the same way, master will assume that the particular data node is alive when it receives the heartbeat signal. Okay, at what intervals the heartbeat signal will be sent? At every 30 seconds. At every 30 seconds, for every 30 seconds, the slave node will send a heartbeat signal to the name node. For every 30 seconds, the data node will send a heartbeat signal to the master saying that I am alive, I am alive, I am alive. Okay, every slave node has to send a heartbeat signal to the master. It represents that that particular data node is alive. What if the master did not receive any heartbeat signal from so and so data node? What if the master did not receive? Who is the master? Name node. What if the name node does not receive any heartbeat signal from any of the slave nodes? At that time, the name node, the master, will wait for 3 heartbeat signals. Will wait for 3 heartbeat signals, meaning 90 seconds it will wait. Till within that time it didn't receive the heartbeat signal from so and so data node, then the master assumes that that particular data node got crashed, got failed. It waits for 3 heartbeat signals. Within that time, if it didn't receive any heartbeat signal from the data node, then the master assumes that the particular data node got crashed. Okay. In this way, the master knows that that the slave nodes are working or not through the heartbeat signal. A very important interview question, students. How come the master knows that particular data node is working or failed? Through the answer is through the heartbeat signals. Okay, fine. So we have seen seen one issue. We discussed the solution also, and one more thing we are going to discuss in this scenario, that is, students, assume one data node got failed. Assume one data node, that is data node 3. Data node 3 got failed. Okay, we have data node 3 got failed. Fine. So the master won't receive any heartbeat signal from the data node 3. Okay, it won't receive any signal from the data node 3. It will wait for 3 heartbeat signals. Until then it won't receive. So it assumes that that particular data node got failed. Okay, fine. Now students, if you think carefully or deeply, now the blocks which are stored in data node 3, those are B2, B4. Those are B2, B4. The blocks stored in data node 3 are B2 and B4. We are losing that blocks, isn't it? We are losing B2, B4. You may say that, ma'am, we are having replicas. No, the replicas are stored in some other data nodes. No? So we won't lose any data. We won't lose data. But here one more issue will arise. What is that issue? If I lose B2, B4 blocks, if this data node got failed, the blocks which is stored in that data node, those are B2, B4. These blocks will become under replica. These blocks will become under replica. What is the replication factor? 3 is the replication factor. But if you see this cluster, as I said, the data node 3 got failed, B2, B4 replica will be only 2. B2, B4 replica will be only 2, which is under replica. There is a term called under replica, over replica. If the replication factor, if the blocks which are stored in the cluster is not the 3, then it becomes under replica. If the blocks which are stored in the cluster is above 3, then we will call it as over replica. So here B2, B4 blocks are under replica, meaning we have only 2 replicas. But at any time, what did I say in the earlier? At any time the replication factor is 3. It should be 3. But now B2, B4 blocks replication factor is only 2. If you observe the cluster. So now the master knows that. The master knows that the data node 3 is not working. So what it will do immediately is, it won't receive any heartbeat signal. So immediately it pull out the metadata file. It pull out the metadata file, searches the metadata file in such a way that where all these B2, B4 blocks are replicated. Where are these B2, B4 blocks are replicated? The B2, B4 blocks are replicated in data node 1. In data node 1. B4 is replicated in data node 1 and B2 is replicated in data node 4. B4 is replicated in data node 1. B2 is replicated in data node 4. Those information will be get by the name node through the metadata file. Once it gets that information, it immediately contact those data nodes. Which data nodes? Data node 1 and data node 4. Data node 1 and data node. It immediately contacts data node 1 and data node 4 saying like, hey data nodes, the blocks which are stored in you, those are B4 and B2. B2 and B4 are under replica in the cluster. So you need to copy the blocks which are stored in you to the so-and-so IP address. Another slave machine, it will pull out from the cluster. It will pull out from the cluster and in that data node, these 2 blocks, B2, B4, which are under replica, will be stored. Now, in this case, in our architecture, those copies are stored in 9th data node. 9th data node. Why only 9th data node? We will discuss that. Till now, clear students? I will repeat once again. But once the data node got failed, the replica will be under replica. Meaning, the replication factor should be 3. It won't be 3, it will be lesser than that. In order to maintain that constraint, that rule, that figure, the master has to act accordingly. What the master will do? Master will get the enough information, like so-and-so data node is not working. So it immediately pull out the metadata file and checks what are all the blocks are present in that crashed node. B2, B4 are present. So B2, B4, those blocks will be replicated in some other data nodes. So it will check in which data nodes those blocks are replicated. It was replicated in data node 1 and data node 4. You may say those 2 blocks are replicated in another slave nodes also. It won't pull it randomly, but whichever data nodes are nearer to the master. Here data node 1, data node 4 are nearer to the master. So only pick those 2 data nodes. In data node 1, B4 is there, in data node 4 B2 is there. So it will pull those, it will select those 2 nodes and it will send a request saying that, hey data nodes, the blocks B2 and B4 are residing in you. Those blocks you need to copy it in so and so slave machine. Which is a slave machine here? It was taken the 9th slave machine. Why only that slave machine it has picked? We will discuss that. So now the data node 1 and data node 4 will send a copy of block B4 and B2 to the data node 9. Now check it once. The replication will be 3 again. The replication will be 3. All the time I said, all the time the replication factor should be 3. Okay students, fine. Now you'll get a doubt like why the master picked the data node 9, why not the other data nodes? If you see the cluster students, every data node is having minimum 1 block. Every data node is having minimum 1 block stored in it. But except the data node 9. Data node 9 does not contain any blocks. It was empty. It is empty actually. So here the master has to balance the load in the cluster. Very important feature or a characteristic of HDFS, of master node, name node. The name node has to balance the entire cluster. Has to balance the work of the storage of entire cluster. Here if you see the slave nodes, there are 9 slave nodes. Among the 9 slave nodes, 9th slave node is not having any data stored in it, which is not where the cluster is not balancing. Every data node should get equally distributed data. At least, not equally, but at least to some percentage it needs to distribute the data. In data node 9, there is no blocks present. So only the master picked that particular data node and stored the copy of B2 and B4 in that. The load balance will be done. The load balancing of the cluster needs to be done. That will be done by the master. Master will take care of the load balancing thing. Understand students? This is the entire Hdfs architecture. We have discussed many things. I just go through once again this video. If you have any doubts, still if you face any issues or doubts, you can contact me. You can put it in the chat box or you can mail me, whatever you like, whatever the medium you like. Okay students? So this is the entire Hdfs architecture. Hdfs is for storing the big data into the cluster, group of machines, group of commodity machines. So I'll summarize the entire Hdfs architecture now. First we discussed why Hdfs. Why should we, what is the use of Hdfs? Hdfs stands for Hadoop Distributed File System. It is used to store big data, large volumes of data, some petabytes of data, yottabytes of data, zettabytes of data. For that purpose only we are using Hdfs. Hdfs is a component of Hadoop. Hadoop contains majorly 2 components. Storage component, processing component. The storage component is Hdfs. Okay. The next one is we have also discussed cluster. What is a cluster, students? It is also an important question for the interviews. What is a cluster? Cluster is in this scenario I am speaking. Cluster is a group of machines interconnected with each other. Group of commodity machines interconnected with each other is known as a cluster. And we have also discussed different Hdfs daemons. Hdfs daemons are name node, data node, secondary name node. There are 3 Hdfs daemons. Name node, data node, secondary name node. Name node versus data node also we have discussed. What is the difference between these two? What are the roles played by those 2 daemons? Name node stores the metadata. It is a master node. There will be only one master in the entire cluster. Data node stores the actual file data. There will be n number of data nodes, n slaves in the cluster made up of commodity machines again. The data nodes will be running in the commodity machines and it stores the actual data. The master, these are slave nodes. The master will be always communicating with the slave node. That is, the name node will be always in communication with the data node so that the entire cluster works in a healthy environment. Okay. And we also discussed what is metadata, block size, replication factor. Metadata means the data which describes about another data. In this case, the metadata describes about the original data stored in the data nodes. Similarly, block size. The block size depends on the Hadoop version actually. Hadoop 1.x version block size is 64 MB. Hadoop 2.x and above versions has the block size as 128 MB. The replication factor is 3. Again, you can configure this replication factor. I mean, you can edit, you can change this replication factor according to your requirement or according to your sensitivity of the data. In which file you are going to change these configuration, students? In hdfs-site.xml. Similarly, we have seen few problems, few issues or few limitations or few drawbacks of Hdfs architecture, and also we have seen the solutions for it. What are those problems, students? What if the data node gets failed? What if the name node gets failed? Who will send the block report? What is the purpose of heartbeat signals? What if the data node gets failed? If data node gets failed, we are taking the replication. Once the data node gets failed, we are not going to lose the data, but still it becomes under replica. At that time, the master will act accordingly. The name node failure. The name node failure in 1.x versions, they have come up with a solution saying like run the name node not in the community machines but in the high-end machines. And in a Hadoop 2.x and above versions, we are taking the complete backup of name node, that is standby name node service we are running in another machine. The complete backup of name node. And the block report will be sent by the primary replica, primary data stored in the data nodes. Those data nodes only will send the block report to the name node. Two things you need to remember, students. The name node and data node. Data node will send two information. It has to send two things to the name node. Data node has to send two types of information to the name node. One is block report. When will the block report will be sent from data node to the name node? This is also one of the interview question. When will the data node send the block report to the name node? Whenever a new block is stored in it, whenever a new block will get stored in it, at that time the block report will be sent by the data node to the name node. And another one is heartbeat signal. For every 30 seconds, data node has to send a heartbeat signal to the name node saying that it represents that particular data node is alive. For every 30 seconds, it needs to send. If it is not able to send that data, it means that particular data node got crashed. There is one more case here, that is, in some cases, the data node will be alive. The data node will be alive, but because of the network issues, in the cluster, the data node has sent the heartbeat signal, but it didn't received by the master due to the network issues. Network bandwidth issues will be there. At that time, sometimes it may happen like data node is alive, but still the heartbeat signal won't be received by the master due to network issues. At that time also, the master assumes that particular data node got failed. Though it is working properly, but still that architecture was designed in such a way that particular data node got failed. It abruptly closed that data node. It abruptly take out from the cluster that data node and put it aside, and it will pull out another data node and make those blocks run in this data node. Okay, students, and we also discussed about block report and heartbeat signals as I have discussed now. These are all the things which we covered from past 1 hour 15 minutes onwards. This is entire summary. Very, very important architecture, both for the exams as well as for the interviews. This is the heart of the Hadoop. We can say that Hdfs architecture is the heart of the Hadoop. Without storing the data, what is the next step? Processing the data. Without the data, are you going to process the data? No. You cannot do that. So this is the heart of the Hadoop. Hdfs is the heart of the Hadoop. Okay, students? Fine. So students, till now you have listened my class. With that knowledge, try to understand the following questions. Whenever you get some free time, try to answer these questions. Again, I will be discussing these questions in my next class. Okay, but try to solve it. Try to answer this. What is the first one? Core components of Hadoop, Hdfs, not Hadoop, Hdfs. Next one is default block size of Hadoop 1.x. Name node versus data node. Who will write data into data nodes? Very important question. Who will write data into data nodes? There will be two persons, master as well as client machine. Among these two, who will write the data into data nodes? Ideally, what should be the replication factor in Hadoop? What is the replication factor? Ideally, by default, I'm asking. What is the reason of increasing block size in Hadoop 2.x? So very interesting question, very important question. What is the reason of increasing block size in Hadoop 2.x? What is the block size in Hadoop 1.x? 64 MB. In 2.x, 128 MB. Why did they increase the block size? What is the reason behind it? Okay. Next one is what is meant by SPOF? Single point of failover. What is meant by single point of failover? Okay, students. Thank you and have a nice day.